Okay, so for problem 4.7, let C sub 0, okay, so this is a C sub 0 written in curly font. So let C sub 0 be a circle of radius r, right? So let me have this r, okay? And let D sub 0 be a square inscribed. I think this is a D. Well, okay. Be square inscribed in C. Maybe it's an S, but I can't read it correctly. Okay. So square inscribed is something like this, right? And then we inscribe it's C sub 1 be the circle inscribed in S sub 0, for instance. So we inscribe the circle inside. So we have this square. We inscribe a circle, and inside the circle we inscribe another square, and so on and so forth. Okay, so we obtain a sequence of circles with a radius, with radii Rn. Okay, with n from 0 to infinity. So what's the sum of the areas of these infinitely many circles? Okay, so the let's see. So suppose we have a circle, with a radius r sub n, okay, in general. Okay, now the side of this, let's see, the square, if you compute this is r sub n, and then this is r sub n, right? So this is just an application of Pythagoras theorem, right? This is the side of the square, and these are the two radii of the circle, and the equation for this is 2rn squared, right? So Rn is let me see, L is the square root of 2 times Rn now, okay? But now if we take that L, okay, and we inscribe the next circle, okay, the next circle will have radius r sub n plus 1, right? So this is equal, as you can see, r sub n plus 1 is L over 2, okay? So this is equal to 2Rn plus 1, okay? So we can get this part of this, and so we can get this recurrence relation, which is Rn plus 1 is Rn divided by the square root of 2, with R0 be R, okay? Now the question is, what is the sum of the areas of these infinitely many circles? Now we have recurrence relations for the radii of the circles, which is the only thing we need to compute the area, right? So we have the area of the circle n plus 1 is just 2 pi, sorry, not 2 pi, pi r n plus 1 squared, okay? But what's n plus r sub n plus 1 squared is this, okay? So this is pi times Rn squared over 2, okay? And we know that a sub 0 is pi r squared, okay? Okay. So now with this recurrence, you can see it's easy to write a sub 0 is pr squared. Now a1 is, well, if you can see, this is pi rn, which is squared, which is the area of the nth circle over 2. So in this case, this is pi r squared over 2. The second area is pi r squared over 4, and so on and so forth. Okay, so the sum from n equals 0 to infinity of a sub n, the areas of this, is just, it's easy to see that this is pi r squared over 2 to the n. Okay, so this is pi r squared times the sum from n equals 0 to infinity of 1 over 2n. Okay, this is the geometric series with parameter 1/2. So this is convergent, and we know that the value is 2. Okay, so the sum of the areas of the circles that are constructed in this way is 2 pi r squared, where r is the area of the original circle.